Hello. Today we're going to be graphing linear inequalities. So in the past you have solved inequalities. I'm going to bump off to the side here. You've solved inequalities that look somewhat like this. And when you solve it, you got answers like x is greater than -2. And what that means is any number bigger than -2 works because when you plug it in, you get a true statement. So notice these ones are compared to 0. Today what we're going to do is we are going to solve inequalities when they're compared to y. So we're not looking for just values of x that make this inequality true. We're looking for values of x and y and their relationship together that make this inequality true. So looking at this, what we're going to do is we're going to treat this like it says y equals x minus 1. So we're going to start with that and we're going to graph the line. So if we go ahead and start with -1 as our y-intercept and our slope of +1, we can create all of our points. Now I'm not going to actually connect the line yet. I'm just going to create this boundary of all of those points there. So now what we're going to do is we are going to kind of look at all of these points here and we're going to plug them into our equation. So we're going to plug in 0 for y and 0 for x. And we're plugging them into our equation up there. So we would get 0 is less than 0 minus 1. So 0 is less than -1. So we ask ourselves, is this true? And since this statement here is not true, 0, 0 is not part of the solution. So I'm going to draw a small x here at 0, 0, just visually showing that 0, 0 does not work. Now how about 0, 2? So I'm going to plug in 0 for x and 2 for y. So I'm going to say 2 is less than 0 minus 1 or -1. This statement is also not true because when I plugged this in up here, I did not get a true statement. So 0, 2 is not a solution. How about 0, -5? So again, I'm going to plug this in for x and y. I get -5 is less than -1. This is our first one where, yes, this is true. So 0, -5 works. How about 6, 0? Y is 0, x is 6, so 0 is less than 5. That is also a true statement. So 6, 0 works. How about -3, 7? So 7 is y, -3 is x, so 7 is less than -4. Nope, there's another one that does not work. So -3, +7 is up here. That point does not work. So looking at our graph, so far everything on the top half does not work and everything on the bottom half does work. So that's kind of what's getting our inequality here. So 4, 3, this one is 4, 3. It's this point right here. So now what we're trying to do is we're trying to see if the points on the line work. So when x is 4 and y is 3, we get 3 is less than 4 minus 1, or 3 is less than 3. This one is no. This point itself does not work. So what's happening here is everything that is underneath this line here, you can test any one of these points. If you want to pick a random point down here, as long as it's in this bottom half of this region, any point down here is going to make our equation true, or our inequality true. So this down here would be your solution. On the line here, we tested a point on the line, and because 0 is not less, or 3 is not less than 3, the points on the line don't work. So what we're going to do to show that is on this line here, we're going to do a dashed line, or dotted line. And the reason it's dotted is because these points don't work. They're not part of the solution. Okay? And excuse me, and that was dictated by this inequality here. because it was just less than. So now let's take a look at another example. So those are your steps here. We can simplify things. We're not going to have to test a ton of points anymore. Now we're just going to have to test one point to see where to shade. So we're going to go ahead and write this in slope-intercept form. Step number 1, check, that's done. Now let's go ahead and graph, okay? So let's go ahead and put our y-intercept at 5 and our slope of -3. And so we get a bunch of points on our graph. Now we have to determine if it's going to be a solid line or a dashed line. Now, if it's just less than or greater than, it's a dashed line because your line itself would not make your inequality true. If your inequality has that line underneath, that is going to mean that the points on the line work, so you're going to show that with a solid line. So for this one, notice how our inequality here is just less than. That means it's going to be a dotted line. Okay, so we're going to go ahead and not connect the whole line. You're just going to do a dotted line as you go. So now we need to determine where to shade. So we're going to pick a test point. The idea of this is either this half is going to be shaded or this half is going to be shaded. So we need to figure out which half is going to work. So what I'm going to do is I'm going to pick a test point that is not on our line. So to me, 0, 0 is a really nice test point because when you plug it in, things cancel each other out. If I plug in 0 for y and 0 for x, this part goes away because 0 times anything is still 0. So we're asking ourselves, is 0 less than 5? If you get a true statement, that means 0, 0 works and it's part of the solution. So therefore, we're going to shade the part with 0, 0. If 0, 0 did not work, you know that everything on that side of the line doesn't work, so you don't shade that side. Let's go ahead and try another one here. So notice this one is not in slope-intercept form, so we need to get it to be in slope-intercept form first. So we divide everything by 3. We get y is greater than or equal to 2/3 x minus 4. So we're going to graph this in slope-intercept form by going down to 4 and putting our point, and going up 2 and right 3, or down 2 and left 3. This is going to be a solid line because you see the or equal to in your inequality. So we draw a solid line. We are going to pick a test point. Again, it can be any point not on your line. I always tend to go to 0, 0, but if your line goes through 0, 0, you have to pick a different point. You plug it into your original inequality. So we're going to do 3 times 0 greater than or equal to 2 times 0 minus 12. We get 0 is greater than or equal to -12. And so that means that this point 0, 0, since 0 is actually bigger than -12, 0, 0 works, which means the half of our graph we shade has to include 0, 0 because it's supposed to work. Let's go ahead and try another one. So we're going to get this in slope-intercept form by solving for y. We're going to go ahead and divide everything by -1. When we do that, as a reminder, we have to switch our sign. We are now in slope-intercept form, so we can graph our equation in slope-intercept form. This does not have the line. That means it's going to be a dotted line. So we're going to connect this by dashing or making it a dotted line. We're going to pick a test point, and I'm going to test 0, 0. But once again, I'm going to go back to my original equation so that if I forgot to flip the sign, I can still shade the correct side. So I'm going to plug in 0 for x and 0 for y, and I get 0 is greater than 1. This is not true. So that means this point right here cannot be shaded. So I don't want to shade the part that has 0, 0 now. I want to shade the part that doesn't have 0, 0 because I know 0, 0 did not work. So that would be my graph of this. And the graph of this shows the solution because all of the points that are shaded should work. So now there's a couple of different things, just reminders. We could have vertical or horizontal lines. The lines are going to be vertical if it's x equals a number, and it's going to be horizontal if it's y equals a number. So for this one, if we're comparing x to 3, we're going to go to 3 on your x-axis, and you're going to draw a vertical line through there. It is going to be a solid line because of the or equal to. We can still test the point 0, 0, but there is no y value, so you're only going to plug in your x value. 0 is greater than or equal to 3. That means 0 does not work because 0 is not greater than 3. So we want everything on the other side of the line. To think about that a different way, we want all of the x values that are bigger than 3. So looking at your graph, everything to the right has x values that are bigger than 3. Which then means this next one is kind of the flip of everything. This one is going to be a dotted line. We're going to go to 2 on our y-axis and draw a dotted or dashed line. When we test 0, 0, we get 0 is less than 2. This is a true statement, which means 0, 0 works. So we want to shade the part with 0, 0. And thinking about that, those are all of your y values that are less than 2. So that's how you do the graphing, including vertical and horizontal lines. The very last thing is now we can kind of work backwards. So looking at this, in order to write the inequality, what we want to do is first we want to write this in slope-intercept form. So down here, my y-intercept is -3. My slope here I can count is up 1 over 1. So I'm going to have a 1 in front of my x. I know that for my inequality, this has to be equal to because of the solid line. So now I need to figure out if this is going to be less than or greater than. So looking at this, 0, 0 worked. So you can always do 0 compared to 0 minus 3. And since 0, 0 worked, we need a true statement, which means 0 has to be bigger than -3. Okay, so you can work backwards by saying this had to have worked because it's in the shaded region, or you can use the general rule of thumb that anything shaded above means it's greater than, anything that would be shaded below would mean less than. Okay, so there's two different ways you can kind of do that. So let's try that second way with B here then. So my y-intercept is 0. My slope here, I want to find the next nice point here. So I'm going up 1 over 3. So 1/3 is my slope. This is going to be a dotted line, so it's not going to be equal to. So if this would have been shaded above, we would use the greater than symbol. Since this is shaded below, that's the less than symbol. So this is y is less than 1/3 x. So thank you very much for listening. I hope this helped. If you have any questions, please let me know.